Welcome back to my channel, everyone. In today's video, we are going to be talking about developing complex software systems. And specifically, we're going to be talking about how these types of systems are built. So there are a couple different angles that we could take on this. There's the actual implementation. There's the actual building of the complex system. And on this level, it requires human beings. It requires people to put time and energy into thinking about the software that is being built. And the other part of this side of things, the implementation, is that you also need feedback on the systems that are being built, which means that you need people that are using the system. So there needs to be use cases for the software that is being built. And this might seem, kind of obvious to more seasoned software engineers that it's basically saying that your software needs to be usable. It needs to be something that is actually being used in production, in a live environment. There needs to be a reason for building this software. But for many people that are just learning programming or getting into software development, that might not be very obvious. It might seem like you just kind of build software. You just you have this idea about some software that you want to build, and then you go and build the software. But software development is very nuanced. There are many moving parts to the software development process. And in order to refine the system and build it in a specific way, there needs to be this set of use cases. And I like to think about software development as taking human level ideas and processes that are familiar to human beings and putting them into an automated solution, into a system that can manage those processes automatically. And the more clearly that you can define these mental models and mental processes, the easier it's going to be to then translate that into code, into an actual system. And it's better for the developer and everybody involved if the system that you're building, the software system, resembles the human level mental models as much as possible. And there's a specific sort of like approach to software development that's called domain-driven design, which basically says just that your software should resemble the domain as much as possible. And along the lines of like getting that feedback, that's where systems or frameworks like test-driven design come into play, because test-driven design is meant to give you that feedback as quickly as, like, you're basically writing your code with that feedback constantly happening. You're writing your code and constantly testing it. The problems with test-driven design could be that now you have two things that you have to maintain. You have to maintain your software. You also have to maintain your test. And if your tests aren't up to date, then there's really no point to the test anymore. And if you have to make some change in your code, you have to be very disciplined about your development, because if you want to change your code, you first need to change your test. Because if you just go in and change your code, your tests are failing. Now, like, the whole purpose of test-driven design is kind of defeated. So it needs to be very disciplined, but it's a way of getting that feedback. And I think the development of the test, this kind of probably goes without saying, but the development of test is a skill in and of itself. And the developer needs to be able to identify what tests are worth creating. You don't just create tests. There needs to be specific types of tests that are created that do just that. They test your system. They will give you that feedback and make sure that your system works in the way that you expect. But bad tests can make the development much more challenging and give you a false sense of security. Maybe security is not the right word, but gives you this false sense of progress or false sense of reassurance that your systems are working the way that you want them to work. Ultimately, I think that you eventually need to bring your systems into the real world, into the use case where it's actually being applied. And that feedback cycle is going to be slower because now it's human to human communication. So there needs to be some way that the humans that are ultimately going to be deriving value from your systems can communicate the effectiveness of the solutions that you've developed. And if you can capture a way of building in that feedback cycle into your development process, then you're on your way to building a complex system, because that means if you are getting that feedback, that means that there is value. That even if the feedback is negative, the users are giving you feedback. They're saying that, hey, this doesn't work as I expected. I need it to work. I need this to work. So if you can capture that feedback, that's a good sign that you're on your way to developing the system. So this is one side of things, right? We started out talking about, I said that we're developing complex system. There's the actual implementation of it. There's the implementation of actually building the complex system that requires human beings, that requires engineers, that requires users. These are necessary components to building a complex system. Because I feel pretty strongly that if you're just writing software and nobody's using it, it's not going to evolve into a complex system. It's not going to evolve, basically. There's no way that there's no pressure for that system to evolve over time. The other important part about developing complex systems is the incentive structure for those human beings. And that's where value creation comes in. And value creation needs to happen on the developer side as well as on the user side, on the people problem side. There needs to be value in both sides of these, on both sides of this, in order for the system to evolve and develop over time. And if you think about complex systems that we're more familiar with, perhaps like biological systems, you can think of value creation as like the energy of the system. So if you want to develop a human being, how do you develop a human being? Well, you could talk about the genetic expression of the human being and the proteins that are required and the assembly of the proteins into specific larger structures that result in like a human brain, and then the connections, the neural connections within that brain, and all of these physical components are part of this complex system. But in order for this physical system to assemble, to build itself, it needs a continuous stream of energy, of inflow. And that inflow in software development is money. It is resources of some kind. So there needs to be value creation and inflow of financial resources to support the developers as well as the users. There needs to be significant reason for the software to be developed. And sometimes it's difficult to pinpoint exactly where these resources are coming from. But even if you take open source software examples, and you might say like, well, look at these, like this software is just developed by a bunch of hackers who just love coding, and that's why the software is being developed, because there's this love of coding. And I think that can definitely get you somewhere, but ultimately there needs to be value creation. We can take Linux, for example. Linux is, as far as I know, it's open source development, and I don't think that there's a for-profit entity around the core development of Linux. I could be wrong about that, but from what I know, I believe it's non-profit. Okay, but even if it is for-profit, the original development of Linux was definitely just one guy writing software. He's kind of like a hacker. But now looking to today, considering the complexity of the Linux operating system and the many branches of it too, because there's not just one form of Linux, there's many forms of Linux. It's very complex. If you consider the entire Linux ecosystem, it's a very complex ecosystem, very complex set of software. And considering like Linux with GNU, that's probably one of the most complex software systems that we've developed. And there's significant value creation and significant amount of resources going into Linux operating systems. Even if you just think about the simple case of deploying a server, deploying a simple Linux machine that's functioning as a server for like some website, and that website is maybe it's like an e-commerce store or something. It's difficult to pinpoint it exactly, but that e-commerce store is essentially built on top of Linux. It's not close enough to the value creation, but we needed to develop that like base, the base which is Linux, in order to develop those higher level abstractions. So the people who were able to understand the value of a system like Linux were obviously more intelligent in software systems than many other people, but there was clearly value creation there, and that was what ultimately supported the growth and development of the Linux operating system. There are smaller examples that exist today, okay? And like open source software seems to be the way that software is developed. Complex software systems are developed. Unless you're a company with significant resources and significant value creation already established, and you have the ability to take funds from your existing enterprise organization and just sort of like funnel that into your software, continue on that value creation cycle and continue pumping funds into your software, and you're going to make it closed source software, and you can pay the money that it takes to scale that software significantly. That's one route to go, but that takes significant amounts of funds. It takes a lot of money and a lot of value creation in order to establish something like that. And it's usually just the large companies that can manage projects like this. So you can, I mean, there are many examples like of this, like of middle tier companies, because companies that are doing like hundreds of millions of dollars in revenue, or even tens of millions of dollars. Like if you're building software with tens of millions of dollars, then you can build fairly complex systems, even a few million, and especially if you've been going over a long period of time. Like I know some companies that have been in existence for like 20 years, and their revenue is under $5 million, but they've been primarily developing software for like 20 years. So they understand the domain, and they're able to build this software. But the complexity of this system is naturally less than like a company that is putting in tens of $millions into the software development process. And also and that's related to like the value creation. All right. So if you're building software that's doing under $10 million in revenue a year, then like there's sort of like there's less value creation in the economy for that software. And if there's software that you're building that is doing over 10 million into over $100 million, that is a significantly more complex system and probably requires hundreds of engineers, at least over 100 engineers. You have over 100 engineers, maybe hundreds of engineers, maybe even thousands of engineers. And one approach to doing this is doing it in this closed source way, but you need the funds. You need to have value creation established. And another way is through open source software, where the value creation is understood by multiple entities, and the funds that are being that are being directed into the development of the software is coming from these individual companies that might be a part of the development of this software, as well as a specific business models that have established around the core development of the software. So we can take a few examples. One of them is MongoDB. So Mongo is a database system. It's open source software, and there is a cloud-based product that has formed around this. So that's one form of the business model. I believe that they started with more of like a service type business model where you could hire the team for services related to MongoDB development, and that's a very good way of getting started. And if you think about like the development of software as it becomes more and more complex, in these beginning stages, doing something like outsourcing services for this software, that is a very good way of just maintaining your core development team and maybe like slowly expanding out the team and the software, like building the software. You build it slowly over time at first. And then as you develop more and more software, you now have more leverage because the software is more powerful. And you've established that leverage from the funds of the business model that you were originally working with. Then what Mongo was able to do was as they started, like this growth curve was kind of going up in terms of like the complexity of the software and also the value creation of the software, they were able to establish a new business model. And this new business model required development of new software. So they needed to take the funds that they were getting and the developer time and resources. They were allocating some of that to their existing customers, but then they also needed to kind of like put some of that effort, time, and energy into the development of this new platform to establish their new business model. So that is a very difficult thing to do, and that is what is required if you want to build complex software systems. I think that understanding like the growth curve is important because you can't really just like you can't do too much at once. You have to understand the trajectory that you're on, and that requires a long-term frame of mind for the core developers who are on the team. They need to understand the value of the software and really be committed to developing it over a long period of time. So to me, this is how complex software systems are built. There's the implementation from the software developer, but then there's also the value creation and the economic component. I think that both of these things need to come together in order for complex software to exist. Some of you might be like listening to this and be like, well, I build pretty complex software on my own and like nobody's paying me to do that. But that's not really what I'm talking about. I'm not really talking about whatever you think is complex software systems that you're developing on your own. It's probably nowhere near the complexity of the systems that I'm talking about here, because the systems that I'm talking about here require many developers. They require a team of people working together. And in order to do that, you need to do that over a long period of time, which means that you need to be able to fund the people that are working on that and incentivize them to put their best time and energy into the development of that software. All right, that's it for this video here today. Be sure to like the video, subscribe to the channel, and I will see you next time.